Hello everyone. So today we will learn about this intrinsic semiconductor. Intrinsic semiconductors are known as this pure semiconductor or natural semiconductor or non-degenerative semiconductor. So this is the actual name of this. We can say that intrinsic semiconductor is known as pure semiconductor, natural semiconductor or degenerative semiconductor. The outermost orbit in an atom is known as valence band. Okay, on maximum number of valence electron at the outermost is 8. So we are discussing about the crystal structures at the 0 Kelvin of this pure semiconductor. So we have the crystalline structure in this form. So maximum this outermost electron is 4 in this every atom. So we can make this as a whole structure in the crystalline form. And this connected with the covalent bond. One atom connected to the other with the help of the covalent. Similar as the same pattern we can repeat for this making this crystalline structures of the any intrinsic semiconductor. So sharing of electron with the neighboring atom is known as the covalent bond. Suppose that this atom connected this atom, this is called covalent bond. Okay, in one covalent bond there will be the two valence electrons. So one this valence electron and this valence, one covalent bond is two valence electron, this one electron, this one electron. So maximum two electrons will be there in the one covalent bond. At the 0 Kelvin all valence electron are imperfect covalent bondings. Okay, so this at 0 Kelvin intrinsic semiconductor work as an insulator. Energy band diagram at the 0 Kelvin, it means conduction band, valence band filled, completely filled, and the conduction band empty. So this is the energy band diagram at the 0 Kelvin of intrinsic semiconductor. It means intrinsic semiconductors is the number of electrons, number of holes is equal to intrinsic concentration. So we can say the equally number of electrons is equal to number of holes is equal to intrinsic concentration in case of intrinsic semiconductor. At suppose that we want to design this crystalline structure at the 300 Kelvin. See, okay, it means you are putting the value at 27 degree centigrade. So in this case, when the covalent bond is broken, in this it will give the electron and hole pairs in the jumping from valence band to conduction band. So similar as like the electron in this case electron and hole pair jumping from the valence band to conduction become as a free electron. So this is the crystalline structure in this case. Suppose that we are applying the 20 degree centigrade at the room temperature. So crystalline structure is like the electron move from this the valence freely move from this covalent band to here. So this generate the holes. Holes is the backend position of electrons. Okay, so we can say that the at the above 0 degree Kelvin. So you are applying the higher at room temperature. So electron freely move from valence this and break the covalent bond and move outside this covalent bond. So that become as like as a free electron. So we can say that the valence electron hole pairs jumping from valence band to conduction and become as a free electron. So we want to calculate the current in this case. So current in case of the intrinsic semiconductor, we can calculate the current I is equal total current I is equal to IN plus IP. IN here the electrons and IP is the whole current. So in this case, electron is faster than hole. So we can say that the electron current is more as compared to hole current because electron mobility is high as compared to the hole mobility. So this is the actual. Actually, we want to calculate the conductivity of intrinsic semiconductor. It means conductivity denoted by sigma. So this is the combination of this nq mu n plus pq mu q. But in case of the intrinsic semiconductor, electron and holes is equal to intrinsic semiconductor intrinsic concentration. So we can put the value and we can modify this equation, and n is equal to p is equal to ni, then q mu p n plus mu p. So intrinsic this conductivity directly proportional to intrinsic concentration. So we can say intrinsic concentration directly proportional to temperature of the temperature. Okay, so we can say the conductivity is directly defined in this case intrinsic higher the intrinsic concentration, higher the conductivity in case of this intrinsic semiconductor. So resistivity is the inversely proportional of the conductivity. So we can say the rho I is equal to 1 by NIQ mu n plus mu t. So this is now intrinsic conductivity of intrinsic concentration. Suppose that we want to increase the temperature, so this behave as a non-linear variations in case of the intrinsic semiconductor. Disadvantage of the intrinsic semiconductor is very smaller conductivity. Due to this reason, so we can use only prefer the fabrication of this pin diode. So no, this is now this is the very less amount of the conductivity. So we can prefer only the fabrication of the pin diode. So another things we are defining here the recombination. Recombination means the free electron pair with the holes is known as the recombination. During this electron and hole pairs both are disappears. So combining of the electron and hole pair, this process is called recombination. During this recombination, holes and electrons both are disappears. So another thing is carrier lifetime. Carrier lifetime means it is the time interval from breaking of the covalent bond until it recombination. It means this is called as the average lifetime. So this is the phenomenon of carrier lifetime.